Okay, so we're on page 18. I know a lot of students will be out tomorrow, but we're just gonna do this section today and tomorrow. So if you don't feel like if you're not gonna be here tomorrow, I think you can try to get through these 4 pages. It's just 18 and 19, and then tomorrow we'll do 20 and 21. We're just cycling through review, whether it's getting the bases to match, setting exponents equal to each other, using logs to solve for a variable that's in the exponent, or converting from log to exponential form to solve for x. Okay. So we'll see how much we can get through, and if we can get past page 19, that's good, because quite a few students will be out tomorrow, so we can just get all the review all the way between today and tomorrow, and then Friday we'll do graphing. So graphing is a little, you gotta get used to it a little bit. So we'll spend Friday and Monday doing full days of graphing, and then Tuesday, Wednesday review, and then next Thursday is your logs test. Okay, so start with number 1. Okay, this feels easy, right? Because the bases are already matching, so I can just get the bases to cancel out and just focus on solving for x, solving for x. We never have to worry about checking for extraneous solutions unless it's a log or a natural log equation to begin with, right? If this is an exponential equation, whatever solution you get, that's your solution. Don't have to worry about double checking or confirming with the original equation. Okay, questions with 1? Number 2. Right, first things first, how can I get that log base 2 x plus 2 by itself, right? Yeah, divided by 3. Now, there are times when you're taking that 3 and you're moving it up as an exponent, but then there are also times where you're dividing it out, and it is a little bit of, trial and error and just recognition, right? In some cases, you do want to bring it up as an exponent, or if you see yourself having to go through a product property and trying to merge different terms together. But here, we know that we're going to have a much easier path to our answer if I just divide that 3 out and just combine the 6 and 3 rather than dealing with the exponent. Yeah, divide by 3. I want to solve for x, but x is stuck inside the log expression. So what can we do? Yeah, convert to exponential. Right? So when you convert to exponential, I talked about yesterday how there's 2 ways to go about it. Whichever way you're comfortable with, you can do it whichever way. But some students like to see it from one perspective versus another. So here's one option to do it. If I have log base 2 of x plus 2 equals 2, one way to go about it is kind of go through that visual perspective, going around in a circle. So starting with the base, picking up the value, and coming back. Right? So 2 second power equals x plus 2. Right? That's perfectly valid. Here's another way to visualize it. If I have log base 2 of x plus 2 equals 2, there's a special property that allows logs and exponentials to cancel out. So I'm going to raise both sides as an exponent and have 2 as the base. I'm purposely picking base 2 because I know that this is log base 2. And if I can get this to happen, then I can completely remove that out of the equation. And I'm just left with x plus 2 equals 2 squared. Same thing, just different perspective of getting from log form to exponential form. All right, for this one, do we need to check for extraneous solutions? Yes, right, it's a log equation thing. So if I insert 2 in for x, is that safe? Yes, okay, so the only thing we have to worry about is if your parentheses is turned into a 0 or a negative number, then we have to remove that answer and call it an extraneous solution. Okay, number 3. I'll just start number 3. Product property, right? If I see multiple logs either added or subtracted, I'm always going to look for ways to kind of merge them together, right? So product property. Natural log of A plus natural log of B will be natural log of A times B. I want to solve for x. X is stuck inside natural log, so convert to exponential form. Right? What's another way of writing natural log or ln? Log base e. Yeah. So log base e of 4x equals 2. Either go through that circular visual perspective of getting it into exponential form, or you can do this. You can raise both sides with e as the base. Get that to cancel out and just say 4x equals e squared. So whichever perspective you want to do it in. That's okay. Okay, so e squared over 4. E is a number. You can leave it in that exact form, and there's no issues there. Any questions with 3? Take a look at number 4. Similar to number 3, right? We definitely want to merge the 2 logs together, but there's something that needs to be taken care of before we can merge those 2 logs. Yeah, we got to deal with that coefficient of 2. So how do we deal with this 2 here? Excellent. Yeah, okay, so we can't divide because there's this minus getting in the way. Now, if it was this, we can divide, right? But that minus, we can't algebraically, we can't divide by 2. We're breaking some rules there. So the best we can do is we can push 2 up as an exponent. And then we can have log minus log, and we can go through quotient property. So this is one of those cases where right? We're looking to divide, or we're looking to make an exponent. And one way is not going to work, so kind of forces us into that exponent path. Now we can do quotient property, right? Log of u over minus log v equals log of u over v. Right. What's the hidden base? 10. Yeah. I'll get that base to show up and then get into exponential form. You can make everything both sides with 10 as the base. If you do that, log 10 to the log base 10 goes away. I'm left with x squared over 4 equals 10 to the second power. Now I can just cross multiply and solve for x. I forgot to mention, number 3, we should have checked, right? We needed to check for a training solution, but e squared over 4 is positive, and inserting that in for x is not going to cause any issues. Okay, 400 equals x squared. Take the square root, we get plus or minus 20. But can both positive and negative 20 work? Yeah, only positive, right? The negative 20 is going to cause this x to be undefined, or cause log to be log of a negative number. We can't have log of a negative number. Okay, number 5. I mean, if we could get the bases to match, then we can remove the bases. But here, e and 25, they're not compatible. So we're kind of forced to have to take the natural log of both sides so that that exponent can be free to come down, right? So you can take log of both sides, but anytime I see e, I want to use natural logs, because natural log and e just cancels out a little faster. Just less things to plug in, a little less messy. Bring the 2x down, take away the natural log of e, because natural log of e is just 1. And then divide by 2. No need to test or no need to check for extraneous solutions, because this is not a log equation. Okay, what's nice about number 6? Same base, we can just completely remove it. So they're both log base 10. So essentially what I'm doing is I'm raising both sides with 10 as a base. I'm just completely removing it. Just setting the intensity with each other. Okay, this one we do have to check, right? Whenever we solve for x, we need to make sure we double check, because always need to check for extraneous solution if we see logs as the starting point. Okay, what should we aim to do with number 7? Yeah, get the bases to match, right? What's a common base that can work for both sides? 5, yeah. So how can I turn 1/25 into 5 raised to a power? 5 to the negative 2, yeah. And now it becomes much easier, right? You can remove the 5 and just set the exponents equal to each other. Same strategy for number 8, right? Base, what base is shared? 3. 27 is 3 to the 3rd. Again, don't have to worry about, is my solution valid or not? It's not an exponential, it's not a log equation, so any solution I get is part of my answer. Don't have to worry about plugging in and double checking. Okay. 9 and 10 should feel like the previous problems. 9 is really easy, right? Number 10, we can make that 125 what? 5 to the 3rd. Okay, 11. It's a 1-to-1 relationship between 2 logs of the same base. We can remove the 2 logs and just set the arguments equal to each other. But we have to check. Okay, whatever answer we get, we got to check. Is 5 halves okay with both sets of parentheses? Any issues? No issues, right? All right, number 12, 2 natural log of e to the x equals 9. What should we do first? Say it again? Divide by 2. Yeah, let's divide by 2 first. Get that out of the way, and then we can worry about the x. Yeah. Okay. There's already a natural log of e to the x, so there's no need to take a log of both sides. What can we just do here? Bring the what? Bring the exponent. Yeah. bring the exponent down. It's already part of a log expression, so we'll just bring that down and remove the natural log of e, and there's our answer. So I get an idea here. Who's not going to be here tomorrow? If you will. Right. Yeah. Yeah, so I figured that if we can get through these 4 pages today, then we can just get all these problems done, and then we can have Friday to start our new section. Okay, 13. Okay, 13 is a little tricky here. We do see that minus sign. Eventually, we do want to involve quotient property, but first we do what? Yeah, that 2. Now, when that 2 comes up, what's it going to do?
Square both 3 and
Yeah, it's going to square both the 3 and the x. Okay, it's going to square the entire argument. And so that's a little bit tricky because I think the tendency is, we bring the 2 up and we just make it log 3x squared, but it's quantity parentheses 3x squared. So both the 3 and the x will get squared. So that is a little bit different from these other previous ones. Yes, just watch out for that. Every term inside the argument gets impacted by that coefficient turned into a variable. Turned into an exponent. Right, so I'm going to just go ahead and distribute that 2 through, make it log 9x squared. And then I'll do quotient property. Nine and 9 cancels out to be just 1. Get that base to show up. Convert to exponential form. Solve for x. I get plus or minus square root of 10. But then when we make our checks, negative root 10 is not going to get that parentheses to be a positive. So we're only going to keep positive square root of 10. Okay, 14 has a similar feel. What's the first thing we should do? Yeah, let's get that exponent to come up, and then we can do product property, right? When you multiply x squared, you're adding exponents, right? 2 plus 2. Bring the 4 down. I can't get the natural log of x to go away, but maybe I can divide both sides by 4. Natural log of x equals 1. Get that base to show up, log base e of x equals 1, and then convert to exponential form. E to the first power equals x. X equals e. We double check. E is fine for x and for x squared. All right, 15. Get the bases to match. (16) is 4 to the -2. Set the exponents equal to each other. Okay, first step for 16. Yeah, get that 3. You get that 3 out of the way, and we can just focus our attention on that natural log of e to the 2x. Right, exponent comes down. Double check. 5 in for x. No issues. All right, I think we can get through the next 2 pages as well. So let's go to page 20. Notice that the left side is already in log form. You can just bring that x plus 5 down to begin with, and then just solve for x. Number 18, quotient property. Get that base 10 to show up. Convert to exponential form. Solve for x. $4,000 is safe with the x. Okay, 19. 1-to-1 ratio with logs. We can just remove the log and set the arguments equal. That's always that first step, right? If you can get that first step down, everything kind of just falls into place. That's the hardest part, knowing what to do to start the problem. We test -1/2, and it's safe with both parentheses. 8 minus 3 times -1/2, that's 8 plus 3/2, that's okay. 7 minus 5 times -1/2, 7 plus 5/2, that's okay. Okay, number 20, we have, we got to deal with that 5 to begin with, right? Do we raise it up as an exponent, or do we divide it over? Divide over. Now, you could get away with bringing it up as an exponent, but it just makes the problem longer and more difficult to get through. And if you divide by 5, it just quickly gets the number, that 5 out of the way, and completely, don't have to worry about an exponent with that 5. But yeah, in some cases, both ways could work, but there's usually going to be one way that's going to be more efficient and cleaner than the other way. Okay, divide by 5, I have natural log 3x minus 2 equals 3. Get that base e to show up, and then we go into exponential form. Okay, if I insert this in for x, we are able to get the 3's to cancel out. I'm left with e cubed plus 3 plus minus 2. The plus 2 and minus 2 goes away. I'm just left with e cubed. E cubed is positive. There's no issues here. This one is valid. Okay, 21. No coefficient to worry about. We can go directly into exponential form. Twenty-two, same base. Let's make both sides the same base, base 4. 23, you can either bring that 4 up as an exponent or divide by 4. I think it's both way works, but in this case, I think it's faster to just divide by 4, get that 4 out of the way. All right, get that base e to show up, convert to exponential form, solve for x. Double check, 1 over e to the 1/2 is just a really, really small positive number, and that's not going to cause any issues with the argument. All right, 24, I want to solve for x. X is stuck in the exponent. What can we do? What can I do to make it easier to work with that x minus 4? Yeah, take the natural log of both sides. Right? Log works, but if I see e, I like using natural log because I know that they're going to pair up nicely with each other. Bring the x minus 4 down. I like to have it in a set of parentheses, so I just remember that this kind of all kind of sticks together here. Natural log of e goes away. Natural log of e is just 1. Okay, last page. Okay, does anybody still need 23 or 24? That's good. No power property to deal with, no coefficient to worry about. We can just go ahead and directly merge them using product property. Log base e, get that to show up. Exponential form. Divide by 4, take the square root. I do want to talk about the square root for a moment here. Square root of e to the 16, the same thing as e to the 16 raised to the 1/2. Now, what do I do with the 16 and the 1/2? Do I take the square root of 16? What do I do when the exponents are next to each other? Yeah, 16 times 1/2 is just 8. So we take the square root of 4, but the 16 turns into 8, right? So it's we don't take the square root of both the 16 and the 4. The 16 is not in the base level, it's in the exponent level, so it's treated a little differently there. The negative version is not going to work, so we call that the extraneous solution. But the positive version is fine. 26, pretty straightforward. Divide by 4, get that base 10 to show up. Exponential form, solve for x. $27, get the bases to match. 28, take the log away and just focus on working with the arguments. What's that 1/4 turn into for 27? 2 to the -2, yeah. -3 is the only answer I get, and it's not going to work because I can't, it causes one of the two. I mean, if it caused just one parentheses to go to a negative, that's enough for us to remove it. It doesn't work with the 5x or the 9 plus 8x. That was the only potential solution. So it's an extraneous solution, and there's no other solution. So the 28 is no solution. Okay, 29, quotient property. No coefficients to worry about. Just jump directly into quotient property. Once I get that left side cleaned up and merged together, I can convert to exponential form. We'll get log base e to show up. That base e is helpful. We can use that to help us put it into the correct exponential form. Cross multiply. Solve for x. Check your answer. We need to confirm this is valid. 2e to the third power plus 1 minus 1 is still a positive number, so we're safe. Okay, 31, convert to exponential form, or get that log base e to show up, exponential form, solve for x. $31, natural log of both sides. Exponent comes down freely. Natural log of e goes away. Okay, 32, how would you start 32? Divide, right? We could bring it up as an exponent, but we see that dividing by 2 is a much easier path. Okay, exponential form, and then solve for x. 1/18 is safe, no issues with extraneous solution. All right, let me come around, check these 4 pages, 18 through 21. So tomorrow we don't have anything, and then Friday we'll start graphing on logs, okay? We covered the 2 days that I wanted to, these 4 pages, we're just gonna split into 2 days, but we just covered all in 1 day.
I thought I heard my phone last night, I looked down and said 9%. No, she said they were doing 16, right? No, she said I was sending this. Oh, you can now know. Oh, I don't know. She didn't talk about it at all. She just slapped into one other. I'm really good. Where. Oh, you know.